we have to learn how to classify real numbers, how to graph real numbers on the number line, and how to find the absolute value of real numbers. Welcome to algebra. Welcome to algebra. In arithmetic, we use numbers. In algebra, we are going to use positive numbers and negative numbers. Numbers from arithmetic in algebra we will call just positive numbers. This is the same. But negative numbers, this is new type of numbers, and we will focus how to work with negative numbers. And we will continue to practice positive numbers.
Logical path. We will talk about negative numbers and vertical real number line. Then we will switch to horizontal real number line. Then we will talk about scale, and then finally we will talk about two new ideas: positive infinity and negative infinity.
We are going to talk about real number line, positive and negative numbers. Here is a sea level, and we have a long vertical stick, and stick is divided into equal parts. And we have two helpers, ladybug and small crab. Ladybug is moving up, and position of ladybug above sea level we can measure by using positive numbers. And crab is moving down below sea level. So position of crab we can measure by using what we would call negative numbers. What is important here, if you look into positive numbers, they grow from 0 and then 1, 2, 3. They're going up. We have to keep this pattern. So we have to make an assumption that all of these numbers grow from the bottom to the top. One more example. Modeling positive and negative numbers. In this case, our stick is in horizontal position, and middle of the stick we would call origin, and origin represents by 0. From 0, if you are moving to the right, we would call this positive numbers, and it's a good idea to connect positive numbers with money in our pocket. So 1 represents $1, 2 represents $2, positive 3 represents $3, and so on. In real life, we have money, but sometimes we have debt, we have credit. So now, for debt and credit, we will use negative numbers. We don't like them, but nothing we can do, we have to use them. So negative 1 represents, for instance, credit $1, negative 2, credit for $2, and so on. But if you look into positive numbers, numbers grow from 0 to the right. We have to keep this pattern. This is why we have to say all numbers, negative and positive, they grow from the left to the right. And in the left, on the left, you can see arrow that tells us that we can extend this real number line to the left as much as we want, or we can extend this to the right as much as we want.
Scale for real number line. We can select any scale for real number line to fulfill our needs. In this example, I use 5,000 for each cell. What is important here, we have to use the same scale for positive numbers and for negative numbers. And as always, all numbers grow from the left to the right.
We thought that you can extend right arrow further as far as you wish. How far can you extend? Sometimes you will see this symbol, and this is what we call positive infinity. And we can extend left side, and numbers getting less, smaller, and somewhere it will be negative infinity. Let's talk about these two special symbols. In the universe, if origin is somewhere on the star, and from origin, if we are moving to the right, we would say we are moving towards positive infinity. If we are moving to the left, the opposite direction, we are moving to the negative infinity. Nobody knows where positive infinity or negative infinity are. It's just a symbol to show the largest possible positive number and the smallest negative numbers. It's just symbols. But what we do know, that numbers grow from the left to the right, from negative infinity to positive infinity.
Logical path. We will practice using symbols, using the idea that numbers grow from the left to the right. Then we will look for a helper. This nice looking bird will help us a lot to pick appropriate symbol of inequalities, and then we will talk how to read proper inequalities where we will see variables.
Real number line. As you see, on real number line, we can show negative numbers and positive numbers, and numbers grow from the left to the right. Now let's talk about symbols. To compare numbers, we can use these three symbols. If we have two numbers, -2 and -2, what symbol should we use? Let's look into real number line. -2 equal -2, so we can use symbol equal. More complicated situation with inequality symbol. If we have two numbers, 2 and 3, we know that 3 is larger, greater than 2, so we can use symbol of inequality. But question is, how can we know that reaction is correct? I develop a special method. I use a helper, a good tester, because you see, bird is always greater than insect. Bird is very helpful to show what we want to show. If we have two numbers, -3 and -2, which symbol should we use? We have to look into real number line, and we can see -3 and -2, so -2 is greater. We know that -2 is greater. Okay, if we use this symbol, we are not sure. Let's use our helper. Aha! Helper tells us that symbol was wrong. Now we can use another symbol, and now we are pretty sure that we show here -2 is greater than -3. This is correct if we want to read this from the right to the left, but we can read from the left to the right, and it will be -3 is less than -2. Let's practice how to read inequalities. Example number 1. +3 is greater than +1. or positive 1 is less than positive 3. Example number 2. Positive 2 is greater than negative 2, or negative 2 is less than positive 2. Example number 3. If we have variable, the first word supposed to be variable. X is greater than positive 2. And example number 4. X is less than 0.
Logical path to classifying real numbers. First we will talk about counting numbers, numbers which you use in daily life. Then we will move to group of whole numbers, and then we will expand previous group, adding counting numbers only with negative signs. After that we will talk about two big groups: rational numbers, which combine all numbers which we can show in form of fraction, and opposite group has numbers which we can't show as a fractions. And then we will come into conclusion that all rational and irrational numbers we call real numbers. This is why we can call real number line, where we can show all different numbers.
We are going to learn how to classify real numbers. But first of all, let's talk about vocabulary. Word set means collection group of numbers. And here is example, numbers 2, 5, 6, 10. Instead of saying word set, we can show curly parentheses, call them curly brackets. And within the brackets, we can see numbers 2, 5, 6, 10. And what is important here, we have special request. Each element must be unique. The first group of real numbers is a set of natural numbers. Natural numbers are what you use when you are counting one-to-one objects. You may be used them counting pencils or cans of Coca-Cola. When you start counting, you use 1, 2, 3, 4, and so on. You are using the counting numbers or natural numbers. And ellipses, these 3 dots in the end, show that list continued forever. Second group is the set of whole numbers. Whole numbers. They are not fractions, they are not decimals, they are simply whole numbers. The only things that makes them different from natural numbers is that we include the 0 when we are referring to whole numbers. As you see, we expanded previous set by inserting 0. The third group is set of integers. Integers, we have to expand set of whole numbers, inserting natural numbers with a negative sign in front of them. Fourth group is a set of rational numbers. Rational numbers have integers and fractions and decimals. Whatever you can express in the form of fraction, it will be a rational number. For instance, number -3. We can show -3 over 1, and we can plot on real number line. Number -2, -2 over 1, and we can plot on real number line. Fraction -2 over 3, we have to divide it one unit into 3 pieces, and we have to accept 2 of them. Number 0. 0 over 1 is just a 0. Fraction 1 over 3, we have to divide it 1 unit into 3 and accept 1 piece. Number 2. 2 over 1, and it's just a 2. Now you can see that numbers can belong to more than one classification group. Rational numbers can also have repeating decimals, which you can see, for instance, as 0.77777 dots dots dots, which simply means it repeats forever. Sometimes you will see the line drawn over the decimal places, which means it repeats forever instead of having dots. Fifth group is a set of irrational numbers. Irrational numbers don't include integers or fractions. The main request to them is they can't be expressed in the form of fraction. They're not exact number. However, irrational numbers can have a decimal value that continues forever without a pattern, unlike the example above. In example of irrational number pi, which is, as you know, approximately 3.142. But if you look into a calculator, you will see 3.141592653 dots dots dots. And this goes on and on and on. So you have to round. This is why you can plot irrational numbers on a real number line, but it will be approximately because you have to round. Irrational numbers are represented by not repeating, not termination decimal numbers. Now let's focus on a real number line. All numbers, rational and irrational, we can show on a real number line, and we use small circles to show those numbers. Let's look into real number line as there are places for numbers. All spots on real number line represent numbers, and we can show more and more and more and more numbers, and each spot represents a number, so those spots can stand so close to each other that we practically don't see openings, because we can show all number, rational and irrational, on a real number line. So, real number line is a set of points, and each point represents a number, rational or irrational. This is why we don't see openings between points, and we can see a solid line. So we can say all rational and irrational numbers we can call as real numbers, and short notation for the real numbers is letter R. Problem number 1. List all numbers from the given set that are natural numbers, whole numbers, integers, rational numbers, irrational numbers. If you have a set of numbers, it's a good idea to analyze this set. For instance, use your calculator and you will see the square root of 5 is approximately 2.24. Or square root of 3 is approximately 1.73. 2 pi is approximately 6.28. When you finish analysis, now you can answer the questions. First set is set of natural numbers. Numbers we can use to count objects. 1, 4, and 6. Next set would be whole numbers. To previous set, we have to add one more number, which is 0. Do we have 0? Oh yes, 0 over 5 is 0. So next set would be a set of integers. To previous set, we have to add integer with negative sign. Do we have? Yes, negative 10. And then we are moving towards rational numbers. Rational numbers. To previous set, we have to add positive and negative fractions. Negative 2 over 3, negative 1 over 4, and 5/8. After that, we have to work out irrational numbers. It's not difficult. We just need to show what is left over, practically what is not exact number. So it will be square root of 5, square root of 3, and 2 times pi.
Logical path to absolute value of real numbers. First of all, we will talk about vertical bars. Why should we use them? And then we will talk why negative 4 equal positive 4 if you use vertical bars. And then we will expand this to more complicated situation where we can use vertical bars.
Now we are modeling again. Here is a sea and sea level, and we can see positive numbers and negative numbers, and we remember that numbers grow from the top to the bottom, from negative towards positive. And we have two helpers, ladybug and crab. Ladybug is above sea level, and distance from sea level to position where ladybug is 4 units, and crab is below sea level, and the distance from sea level to the position where crab is 4 units. So distance does not use negative values. So to emphasize that we are talking about distance, we have to use absolute value bar, vertical bars around the number. Whatever is coming out of absolute value will be always positive, because we are talking about distance. One more example of modeling. Here we have $5 and credit for $5. Positive numbers represents money in our pocket, $5. Negative numbers represents credit, $5. But what is important here, distance from 0 origin to 5 is 5 units, and distance from 0 to negative 5 is 5 units. This is why absolute value bars around 5 or negative 5, and whatever is coming out, it will be always positive. Using the result of modeling, now we can solve problem number 1. Request is insert symbol of inequality or sign equal in shaded area to make a true statement. Absolute value of negative 5 and absolute value of 5. And because we know whatever is coming out of absolute value bar, it's supposed to be positive. So absolute value of negative 5 is positive 5, and absolute value of 5 is positive 5. So we can insert symbol equal. In problem number 3, we have request to compare absolute value of negative 5 and absolute value of 5 minus 2. Second absolute value bars have 5 minus 2. So it's a good idea to simplify into 3. So now we have absolute value of negative 5 and absolute value of positive 3. Whatever is coming out of absolute value, it will be positive. So first bars will give us positive 5 and second bar will give us positive 3. So now we know that positive 5 is greater than positive 3. Now we can go back and show correct symbols.